Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Aiman bin Muhammad Ruslan. Matrix number KIB190030. So today we will be conducting a lab test for KIB1004 and we will be constructing an RC circuit. Now for the we will be using an AC source which is a sinusoidal source with a frequency of 1 kHz, which is given. However, for the resistor value, we'll be using the integers of our matrix number, which is 30. So multiplied by kilo ohm. So we have 30,000 ohm, and we need to find the capacitor value, whereby the value of XC is equals to R. So we will go to the Excel so we can calculate the value of capacitor. So we have our value of resistor 30,000 ohm and frequency of 1000 Hz. And using the formula in capacitor, using sorry, what is the formula? Xc equals to 1/2 pi Fc. We will invert it and make the C as a subject, and we will plug in the values from the resistor. So we get 1/2 pi multiplied by D6 the frequency and D5 the value of resistor. This will give us the value of the capacitor, which is 5.305 nanofarads. So now we can start building the circuit itself. Now for the circuit, we will have a voltage source, resistor R1, capacitor C1, and R sense, and is connected to the ground. So then we will join it with the wires like this. Okay, now for the parameters, before that, we have to put two voltage pins, VF1 and VF2, one after the resistor and another one is after the capacitor. And then for and then for the voltage source, we will be using a sinusoidal wave which replicates an AC generator. We will have the amplitude of 1, but with the frequency as earlier mentioned, 1000 Hz. We can leave the amplitude as 1, and we will have 1000 Hz or 1 kHz. Okay. So for the value of the resistors, as mentioned earlier, our resistor is 30,000 ohm or 30k ohm. And then for our capacitor, as we have calculated earlier, is 5.305 nanofarads. It will run out to 5.331 nanofarads. And for R sense we only put 1 ohm. R sense is placed there so we can have we can obtain the reading of IC, or the current of the of IC later in the oscilloscope. R sense has to be a small value so that it does not affect the overall circuit, but it allows us to observe the waveforms of IC and VC in the oscilloscope. We will change the mode to auto or normal so we can run. Now we will adjust the horizontal and vertical axis using the time and the volts so we can observe the waveforms better. So for VF1, as you can see, is VC, which is the voltage of as you can see, it represents a sinusoidal wave, which represents an AC wave, AC voltage, AC current. Now for the green, which is VF2, which is IC, as you can see here. So as you can see, there are both sinusoidal waves, but they are have a slight phase shift. Now we can stop the graph, we can stop the oscilloscope and obtain 2 readings from each wave, so we can calculate a phase shift. The readings have to be from each curve which are at the same phase. So I will use the cursor and obtain the reading from the first row, which is the bell shape. Which is the bottom crest. The bottom crest from both curves, so we can calculate the phase shift. Now, once we obtain the once we have found the values, which is our XA and XB, as you can see on the oscilloscope here, it is at 996.39 microseconds for XA, and for XB 750.9 microseconds. So we can now go to the Excel and calculate the phase shift. Now here I've prepared, so we can put in the values of XA, which is, as mentioned earlier, there we go, 0 0.0, and then we can calculate the T difference, which we can obtain from subtracting XB from XA, or the other way around. And then the frequency, as mentioned earlier, which is 1000 Hz, we can get the period, which is 1 divided by frequency. And then from the values obtained here and calculated, we can obtain the missed the 0. So from the values obtained, we can now calculate the phase shift in degrees. So the formula here, we have 360 degrees multiplied by time difference divided by the period. So this is the objective of our lab test today. So we have now obtained negative 88.37 degrees. We also have the value in phase radius. That's all from me. Thank you.